Today's lesson is Unit 1, Lesson 6, Exploring Non-Standard Volume Units. Our objective is to use non-standard units to measure volumes of rectangular prisms and also to understand the concepts of volume. So for virtual, we are going to not be able to do this first one. We're going to try to understand how this process to get us to understanding just the concept of volume. Because a standard for 5th grade is to find the volume of a right rectangular prism with whole number side lengths by packing it with unit cubes to show that volume is the same as it would be by multiplying the edge lengths or multiplying the height by the area of the base. Before we move on, this would be a great time to fill in that notebook that you have and write down the definition of a rectangular prism. A rectangular prism is a prism that has rectangular bases. So an example would be a shoebox. A shoebox is a rectangular prism. In the last lesson when we introduced volume, I showed you a jewelry box, I showed you a storage box. Those are also examples of rectangular prisms. Now, in class, students are going to be doing an experiment with rectangular prisms, boxes, so shoe boxes, any other type of box that has a rectangular prism. So we might have like an iPad box. What I would like you to do if you're at home is after watching this video, there'll be a submission possibility for you in the lesson, in this presentation posting, for you to find a rectangular prism in your house, any size, and upload a picture of it, upload an image. We'll try that, or you can upload a recording of you holding up your rectangular prism and talking about how it fits into that category. Now, I said that they're going to be doing an experiment, and so we do not have access to hand you the pattern blocks today. So I'm going to talk to you about this. So the students are going to use pattern blocks to measure volume of a rectangular prism. And they were going to use square pattern blocks, triangle pattern blocks, and hexagon pattern blocks. Through this experiment, we're going to talk about which one best helps us find the volume. Now, I want us to just refer back to and think back to our lessons last week when we were talking about area. And we knew that we measured area using squares. So because we had square units. So if we think through that and we think about the characteristics of finding area and then moving forward and finding volume, we're going to find that a square pattern block is going to be more useful than using a triangle or a hexagon. Because when we're thinking about a rectangular prism, we know that a rectangle has those 4 sides, those 4 angles. A triangle only has 3 and a hexagon has more than 4. So we know that the square fits that rectangular, those rectangular attributes, the same characteristics. So what's important when you pack the prism with those square blocks or the cubes eventually that we'll be using, you have to pack the blocks tightly as possible. And you don't want to have gaps. You don't want to have overlaps, just like we had with area. It needs to fit in there perfectly. And if you do have gaps, then you know that it's not going to be a great fit. So triangles and the hexagons, those definitely create a gap. So the hexagons were larger, so you had less of them. So what we're trying to get to is you want to have something that is set, that you're always going to get use so that you have a consistent number in measuring, okay? So last week when you measured your cylinders that you created at home, you could have used pattern blocks, marbles, cubes, beans, popcorn, Kleenexes. You could use those to fill up. What you want is something that's consistent though, okay? So when measuring volume, a cube, so you'll see right here, the cube would pack tightly because each face would fit exactly against the face of another cube, and it would also fit into all the corners of the prism. So we're we're talking about those characteristics still, okay? A rectangular prism has those four corners just like a cube would. Those four right corners, and then it has the same amount of sides. So what I'm going to do now is I'm going to come on over here to Khan Academy, and I'm going to show you that we can get to some volume videos and volume exercises, and that's what I want you doing today for your lesson. So I talked to you a little bit about what we're doing in class, but this is what I want you to do virtually. And if I go back to the Khan Academy homepage here, and you can see we have courses. So I think I've shown you this before, but what you can do is you can go to 5th grade. You can start that challenge. I'm just saying no for right now for this. And you can scroll through and you can see there are different topics. All of these are perfect for you to practice whenever you have the time. But I'm going to scroll to the one that says volume. And here you will find there are different videos and activities. So you'll see that you can start and then you can do practice. So we have volume with unit cubes, and here we have volume of rectangular prisms. This is where I will want you to stop. I only want you working on volume with unit cubes and volume of rectangular prisms, and feel free to take the quiz to check your skills. And do not move forward to the decomposing figures yet. We will get to that later this week. But right now, I only want you focusing on volume of unit cubes and rectangular prisms. So here you can watch the volume intro again. You can watch measuring volume with unit cubes. So you'll click start here. And so you can say ready to practice. And you say, let's go. So here they will give you questions. So what is the volume of the following figure? So they're showing us a front view and a back view. And here you can just practice counting because these are not solid rectangular prisms right now. So we can count 1, 2, 3, 4, 5, 6, 7. So I can see that this has 7. And right here I can check it and it'll tell you if you got it correct. So then moving on to the next question, I'm going to show you what happens when you get it incorrect. So let's say that I counted wrong on this. I counted 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's say that I just count to 9 and I type in 9 there and I check. It's going to tell me not quite yet. You can get help or you can skip for now. What you can do is you can use a hint and it's going to talk to you about that. It's going to give you that information. You can use another hint. Okay? You can see here that there are going to be 4 total hints before you can move on. Let's say that you've found your error. You can check again, and it'll tell you. It says, moving on, next question. Okay, so you just keep doing this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And you can see down here where we're at. Okay, get 3 of 4 questions to level up. So we can move on to the next question. I'm going to show you 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Let's see. All right. And then we can show a summary. And so they tell us that we got 3 out of 4. Correct. You can click done. So you can see that we did that one because it says try again. So then it says up next, volume of rectangular prisms. This one has 7 questions. And so you see this is more of a solid rectangular prism part here. What I want you to do, though, is before you do the practice, I want you watching the video here. You can see that 7 minutes.
You could call it a rectangular prism. And I want to measure its volume. And I'm defining my...
And I will provide direct links in the instructions on this presentation so that you can come directly to those videos and then you can find the practice that is connected with them. So that is today's lesson. Again, we are working in class, we were working with those non-standards, but my main goal for you at home is to understand the concepts of volume, especially when connecting to that right rectangular prism. And we're going to get that information today through Khan Academy. And again, those will be linked in the instructions on Canvas connected to this presentation.